throughout the whole class, and I had him, what have I done? Anyways, we're back, we're live. Quiz 1. Oh, got to do my favorite student. Somebody else showing up late? Of course I have to, but I got to get right my name first. Right click. I hope not. So you want your pink periodic table out? I've given my pink periodic tables away. Oh, and you want to make sure you bring your pink periodic tables to the test next week. I will have a couple of extras. I won't have 30 extras. I will make sure that the substitute teacher knows that you are allowed to use your pink periodic table, that they don't think you're cheating. So, name. First thing I have to check is this multivalent? Because if it's multivalent, the name's going to have Roman numerals. Is sodium multivalent? Nah. And that's partly a joke, but partly true. In fact, I think the multivalent started right there. So I'm going to be a bit more, because I know iron is multivalent, I'm going to be a little more paranoid when I get to number 3. But for now, the name is going to be sodium chloride. That gets you 1 mark. In fact, usually what I do is I do a half mark for the first thing, half mark for the second. So half mark for sodium, half mark for the chloride. Total number of molecules in the, total number of atoms in this molecule, 2. 1 chloride ion, 1 sodium ion. Calcium bromide. Okay, now we're going from the name to the formula. I have to use that crisscross shortcut. I say to myself, okay, calcium, which I think is 2 plus, and bromine, which I think is 1 minus. I think that means it's going to be Ca1. Am I going to write the 1? Half mark for a Ca with an invisible 1, half mark for a Br with a 2. If you don't have the 2, you can't get the half mark. How many atoms in this molecule, grand total? 3. 1 mark for that. Iron, multivalent. This is probably the single trickiest topic in ionic bonds. In fact, my grade 10s still struggle with this. Many of them got this wrong. Part of it was I taught it lousy. I taught it better with you guys. I don't know if I nailed it. The fact that it's multivalent, here's what I have to figure out. I actually look at that. What's the charge on 1 chlorine ion from my periodic table? What's the charge on 1 chlorine ion from my periodic table? Minus. How many chlorine ions are there? So the total negative charge is that. For this to be balanced, the total positive charge has to be that. Now, how many irons are there in the front there? It's meant to be obvious. 1. So you know what? It's going to be iron 2 chloride. That iron has to have a charge of 2. Has to. Otherwise, this can't possibly be stable. Oh, and how many atoms? I think a total of 3. Again, 1 iron, 2 chlorines. 1 iron ion, 2 chloride ions. Yo. Then the best you can get is a half mark if you got the chloride, but you lose the whole half mark, you botched it. Right? So half mark for the first part, half mark for the second part. You got the first part wrong, so the best you can get is a half mark for chloride. Right? Does that make sense? I go like this, half mark for that, half mark for that, but if that's wrong, you get goose egg on that part. Oh, if you put a 2, a number 2? You know what? Since it's a quiz, I'm going to ding you on it, because that way you'll get it right on the test, because you'll be annoyed. And that's worth losing the half mark to make sure you get it right when it counts. Yeah. Hudson's shaking his head. Well, I don't care. Next one, copper 1 sulfide. Okay, copper is multivalent. So if I want to figure out the formula, I have to crisscross. Now sulfur, I'm pretty sure, is 2 negative. I'm going from memory, by the way. If I'm wrong, can you guys holler at me? Copper is multivalent. Oh, wait, no, wait a minute. Although it's multivalent, which charge do they insist that they want me to put here? That's what the Roman numeral 1 means. So now when I crisscross, I guess I'm going to get Cu and a 2 there. S, and I'm not going to write the 1. So for you to get full marks, half mark for Cu with a 2, half mark for S with a 1, but no 1. How many atoms? I guess once again 3. I don't know, what did I just finish saying? It's 1 mark, okay, so you ready? It's going to be like this. Half mark for the front one, half mark for the second one, but they have to be perfect each time. So you have to have the right subscript. Right? The subscripts tell you what ratio of each you need. CaOH. Ca. Calcium. OH. Oh, that's a polyatomic ion. How do I know? More than 2 capital letters, and also the brackets is kind of a hint. What's OH? Oh, this is called calcium hydroxide. Do I need Roman numerals? Is calcium multivalent? Nope. So kids sometimes go Roman numeral loopy. They like, oh, it's calcium 2. No, no, no. Calcium is always a 2. We don't need to put it in, just like we don't need to put an unnecessary 1 in. If there's certain things we know, don't bother. How many atoms? This one is tough. Whoop, oh, my pen is going to start acting up. I hope not. That's going to be irritating. How many atoms are there inside that bracket? 2. 1 oxygen, 1 hydrogen. Times 2 means a total of 4 plus 1. This has 5. This has 5. Potassium permanganate. Potassium, multivalent or not? Potassium, multivalent or not? Not? Oh, this is going to be easier. By the way, you didn't need to look at your periodic table. If it was multivalent, what would have appeared in the name? Roman numerals. So all of you, and you look, actually it tells you it's not. So you know what? This is going to be, I got a crisscross though. It's going to be, right now, folks, my pen is acting up and it's leaving little smears, but I'm just going to work with it right now as best I can. K is plus, what the heck is permanganate? I don't know that one at all. M, lowercase n, O4 negative. M, now I lost my pen totally. M, bear with me, going to pause the video. Permanganate is MnO4. Most important, the charge, negative. Oh, this one crisscrosses perfectly. It's going to be K, MnO4. That 4, is it on the O or is it on the MnO? It's just on the O. If I wanted it to be on the MnO, how would I show that? Brackets. So how many atoms now? 4 oxygens, 1 Mn, which is manganese, and 1 potassium. There is a total of 6. CO, I have a feeling CO is multivalent. Is it? Cobalt. Yeah, rats. Okay, so what I'm going to do is I'm going to look at this. What's the charge on 1 Cr2O7, which is called dichromate? One of those is worth 2 negative, according to the back of my polyatomic sheet. How many of those are there? 3. So if each one is worth 2 negative and there's 3 of them, what's the total negative charge? You're going to be asked to do this on your test, folks. This is 2 negative, and there's 3 of them. What's the total negative charge? Negative 6. What does the total positive charge have to be? Positive 6. Except, how many cobalts do I have? 2. So what do I want each one of them to be worth so that it's positive 6 grand total? 3. This is going to be half mark for the cobalt 3, Half mark for the dichromate. That's a tough one. But hopefully you saw, if you don't panic, if you go systematically, you got to do a little arithmetic. You need to know your times tables, but it's not like you need to know your 13 times table or anything. You need to know your 2, 3, 4, and 5 times tables. How many atoms grand total? Okay, I'm going to erase this because this will help me. Let's see. Inside the bracket, there's 9 times 3, 27 plus 2. This has, holy smokes, 29 atoms. 29 atoms. That's a big molecule. Manganese 3 phosphate. Manganese is M lowercase n. It's multivalent. Oh, wait a minute. No, the Roman numeral says they want me to use a charge of 3. Phosphate. Did they say phosphide? No, phosphate. Phosphate, back page, is PO4 3 negative. I'm going to write down an answer. Tell me why it's wrong. Why is this? Why is that wrong? It works for the crisscross, Mr. Dueck. Well, it's not just crisscross. It's crisscross and then do what? Lowest terms. So 3 and 3 lowest terms is actually one and 1, Mn, PO4. So if you got 3s there, sorry, you lose each half mark for that. And how many atoms are there? 4, 5, 6. Mo. What the heck is Mo? Oh, element 42, molybdenum. Oh, multivalent. Roman numerals. What charge? Well, let's see. On CR04, I looked on the back, each one of these is worth 2 negative, and there's 3 of them, so there's a total of 6 negative, or negative 6. So this has to be positive 6, but there's 2 of them. Hudson, if there's 2 of them, they got to be positive 6. What's each one got to be worth? Same answer as before that you remember. Yeah, nice recovery. So this is going to be molybdenum. Did I spell that right? Yep. 3. And then CR04 is chromate. How many atoms are in this molecule? Good question. Inside the bracket, there's 1 chromate, 4 oxygens, for a total of 5 times 3, 15, plus 2, 17. Ammonium phosphite. Ammonium is NH4 plus. Phosphite, not phosphide. Phosphite is PO3 3 negative. When I crisscross, I'm going to get NH4. I guess I'm going to need 3 of them. PO3, I guess just 1 of them, so I'm not going to bother writing a 1. Half mark for each. How many atoms are there? Oh, good question. Inside here, there's 5 times 3, 15, 16, plus 3, total of 19. Can you give yourself a lovely, lovely, lovely score out of 30, please? Give yourself a score out of 30. Sorry? The numbers? These? I think 1. I think if you look, there's... oh, how did I work this, Mr. Dueck? Hang on. Why did I make this worth 30? Okay, 1 mark... You know what? If we go half marks, you're right. It's going to be out of 20, isn't it? I think what I'd initially planned on doing is giving you 1 mark for each name and 1 mark for this. I think I'd made the formulas worth 2. Anyways, do it 1 mark each. Half mark for each formula, half mark for each name, and that. Does that make sense? Vaguely, sort of, kind of? So give yourself a score out of 20. out of 20. And let me pause the video. Can you all please get out the lesson we were working on last day, which was section 3.3, physical and chemical changes. This puppy. Okay? And I think we had finished the front page. And I think everyone was here last day. If you've lost it, sheepishly tell me. I'll get you another copy, but hunt for it first, please. Okay? And I think we left off right here. Is that right? Yeah, we left off right here. I'm saying we filled this in, and this is as far as I got. We talked about physical and chemical changes, so you guys pause right here. I'm going to go to my PowerPoint. I'm going to, again, like I usually do, quickly review what we talked about, and then we'll blaze on through and finish off this whole chemistry unit today. So we looked at a couple of videos talking about physical and chemical changes. We said in a physical change, chemical bonds are not broken. The key idea in a physical change, nothing new is produced. You change the size, you change the shape, but you're not giving off light or heat. There's no chemical reaction. Ripping a piece of paper is a classic one. Usually a physical change is reversible, like freezing and then unthawing, or boiling and then condensing. So we said some other words: tear, cut, boil, dissolve. We said all of the ones from this triangle. I can't say it's always reversible because you can't really reverse ripping a piece of paper in half. But as an example, throwing a piece of wood into a wood chipper. Physical change or chemical change? If you throw a piece of wood into a wood chipper, physical, because nothing new, you're changing the shape of the pieces of wood, but they're still wood. And we talked about chemical changes. In a chemical change, the key idea, you got it okay, Lena? Yeah, the key idea, something new is produced, and it's non-reversible. Usually. There are a few that are reversible, but usually non-reversible. Burning. Anytime you're burning something, whether it's with a fire or like in a flare gun or fireworks, those are all chemical changes. So even if there's not flame, like a firework, when it shoots out the glowing thing, that's still burning. What else? Other words: react, oxidize, which is a fancy word for burn, precipitate. I haven't explained that word yet. I will. Combine, bake, broil, grill, cook. A lot of the reason that raw food often is bad for us, can poison us, but when you cook it, mix it together, you're getting new chemicals combined and something new is produced. And here is the key idea where we left off, I think. If you're trying to decide if a change is physical or chemical, can you put a star next to this? That's really going on your test. I'm going to give you some situations and I'm going to say, tell me, physical or chemical? And really, 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 what you're saying to yourself is, was something new produced or not? Oh, you're sharpening it, or you're using the pencil sharpener. I was like, what the heck is that noise? Okay. So we paused here. Ready, Rihanna? All good? Here we go. Here are some clues that indicate a chemical change. So I told you, Mitra, the basic question, was something new produced? How do you know if something new is produced? Stuff we look for in science. Sometimes new solids form other than solidification. So we're not talking about freezing water, but oh, I've mixed two liquids together and all of a sudden there's a solid that's forming at the bottom of the beaker. That's probably a chemical change. There's a fancy word for that. If you mix two liquids together and you get a new solid, we call that a precipitate. Okay? A precipitate. So, new solids form other than solidification. That's one very good way. Back page of the Back of, flip the page over. Right there. Clues that indicate a chemical change. Okay? Other clues that indicate a chemical change. Bubbling. If the liquid starts to bubble, not boiling though, because boiling is different, that's a physical change. But if you mix some stuff together and you see bubbling, that shows, oh, one chemical is being turned into a gas. There's some kind of a gas being formed. Atoms are being moved around, bubbling. So, Lindsay, we did a lab this year in Science 10 where you drop magnesium into acid, and you could tell it was an acid because bubbles were forming. It was hydrogen. So bubbling shows a gas is forming. A color change. A color change. In Science, it was a vibrating phone, not a ringing phone, right? Sorry? Oh, I missed one? Well, if you guys catch it, point it out. You guys just got Timbits today out. Wow, man. I will get her, and she's in the new year, actually. I haven't forgotten, but I'm going to get Nicole in the new year because I'm not here to supervise it next week. Color change. So there are some chemicals, you mix them together, and suddenly, holy smokes, I have a clear, colorless liquid that looks like water, and I mix it with another clear, colorless liquid that looks like water, and it turned yellow, or it turned blue. Color change. Fireworks. Do fireworks change color? That's a chemical change. An energy change. An energy change. Gives off heat or it sucks up heat. Okay? Gives off heat or it sucks off heat. In particular, if sound or light is given off. Glow sticks. You've all seen those? Those are chemical changes. How do I know? Giving off light. Giving off light. If heat is given off, and here are two words that you need to know. You want to write these down. I'm going to give you some chemical reactions, and I'm going to ask you, is it exothermic or endothermic? Did you guys see those words in Science 8 or not? So these are new. Exothermic gives off heat. Listen close, listen close, listen close. For an exothermic reaction, heat is exiting. For an exothermic reaction, heat is exiting. For an endothermic reaction, it's sucking up heat. Here's what I remember, Kevin. For an endothermic reaction, heat is entering. In fact, endothermic reactions feel cold. Cold packs. Have you seen those ones that you shake, crack, and suddenly they get cold? That's an endothermic reaction. Can anybody tell me a neat little exothermic reaction that gives off heat? Why, Mr. Dueck, you have the, oh, let's pause the video here. So I've given you a great example of an exothermic reaction. I don't have any of the ice packs because I haven't found ice packs that are reusable. For most of those, it's crack them once and you can't reset them. But ice packs are a great example of an endothermic reaction. What else is heat absorbed? Most cooking is endothermic. You add the heat and it swallows it up. Yeah, after you heat it up, it's hot and giving off heat. That's not what we're talking about. Baking, for example, until you add heat, the reaction isn't going to occur. It absorbs heat. Keep going. Oh, Mr. Dueck has a pretty cool, there you go. What type of chemical change is this? Well, even though it's giving off heat, this is a very weird reaction. It is not a chemical reaction because nothing new is being produced. It's sodium acetate remaining sodium acetate. So it's physical. Why? And this is what you can write down. Nothing new is being produced. We're about to. Oh, you know what? I didn't give you a spot for that. That's right. This slide, I knew I was going to hand this out. Okay? You know, but key idea. How do you know the difference between physical, chemical, something new is produced, physical, nothing new is being produced. Okay? Now we're back to a slide, I think. Oh, comic. Exothermic reactions. I studied them before they were cool. No? Okay. Tough audience. Some more terminology, chemical reactions. Now we're back to notes. Ready? Reactants are what you mix together. They're reacting. You react the reactants. Products, that's what's made or produced in the reaction. Next year, you're actually going to start to write these as equations. Lindsay's doing it this year in Science 10. Probably one of the trickier topics in all of science, but when you wrap your brain around it, it's a high nerd satisfaction factor because you're actually predicting ahead of time how stuff will combine. And that's kind of, you almost feel like God. Like, I can see how these are going to combine. They're going to combine this way. Thus saith Mr. Dueck. Well, thus saith the math. They look something like this. Reactants go on the left of the arrow, products on the right, and the arrow means turns into or produces or becomes. Here is an example of a chemical reaction equation. CH4, which we would call, well, methane, it's a special molecule, plus oxygen turns into carbon dioxide and a couple of water molecules. That's Science 10. Lindsay, that's a hydrocarbon. It's an organic molecule. It's also called methane. Yes, it's also technically carbon tetrahydride, but nobody calls it that. Pardon me? No. No, it's just a picture for you. Okay? If you want more information, or as you're studying, you might want to read the textbook section 3.3. But what are we going to work on right now? I have a couple of things. First of all, I have section 3.3 homework. This is on physical and chemical changes. It'll take you probably about 15 minutes. Not very long. So the first part of your homework, and by the way, you're not going to hand this in tomorrow. Hand this in the day of the test. Hang on to this to study from. Hang on. You know what? Let's even put that here. Hand this in the day of the test. Keep it to study until then. What am I talking about? This handout here called Section 3.3 Homework. So walk through this. This gives you an idea of what kind of vocabulary or multiple choice or fill-in-the-blank questions I might ask. Talking about chemical and physical changes. Talking about end. You need to know the difference between those two words. Which one has heat exiting? Which one is giving off heat? Endothermic or exothermic? Which one has heat exiting, which is giving off heat? Endothermic or exothermic? Which one has heat exiting? Which one is giving off heat? Exothermic. If you come up with your own way to remember it, that's what I came up with years ago. Okay? You can fill in the blanks. That, and I did attach the answers. That's due the day of the test. However, I also, on your notes, said this. I have a big naming review worksheet. I'm going to give that to you in a few seconds. Your test is on not Tuesday, December 9th. I wasn't sure when I set this up. Your test is on Thursday, December 11th. Thursday, December the 11th. Nice try, Mr. Dueck. 18th. Okay. And I got one more thing. We have quiz 2. I'm going to give you 2 things then. Let me pause the video. So I've given you Chapter 3, Quiz 2. This is important. Listen. I love example 1. I love example 1. I love example 1. I like question 1. I like question 1. Question 1 is a nice question. Why would I be saying that? In fact, I actually cut and paste this from the test. All I did was I changed this chemical. I changed this formula. I changed that. You're going to see a 20-mark question just like this. Now, in the middle here, I've given you space to do the crisscross rule. It's not for any marks, but I included on your test a spot so that you could do the crisscross to help you. Okay? In other words, your test is done. I photocopied it yesterday. It's out of 59, basically out of 60 marks. 20 marks, 1/3 of your test right there. If you figure this out, if you ace this, you're getting perfect on 1/3 of the test. Zip zap. Then on your test, I'm also going to ask you to draw a Bohr diagram of an ion, well, an ionic compound. You're going to say, Mr. Dueck, I've forgotten how to do this. Go look at your section 3.1 notes. I'm going to push you to study. Turn the page over. Bohr diagram of NaF, of sodium fluoride, I think I would pronounce that. Bohr diagram of magnesium chloride. Okay? On your test, one question is going to be draw a Bohr diagram. I've given you 3 to practice here, but one question is going to be draw a Bohr diagram. That's going to get you through about half of your test, if you can just ace that. Oh, and you know what? Some of that will overlap on the multiple choice section as well. I think there's 20 multiple choice. Then there's a bunch of not matching, sort of fill in the blank. You know what? I'll probably give you some chemicals, formulas, and I'll say match them to the names. I'll probably give you some names, and I'll say match them to the chemical formulas. I'll give you that 20-mark chart. Oh, you know what? I'll probably give you some chemical or physical changes and tell me which ones are chemical, which ones are physical. Maybe 5 of those in a row. I'll probably give you some reactions. I'll say which ones are endothermic, which ones are exothermic. Maybe 5 of those in a row. That's your test. Oh, I may ask you to describe how you know the difference between a physical change and a chemical change. How do you know the difference between a physical change and a chemical change? What's the key question? Something new is produced. That's a chemical change. Physical change, something new was not produced. It's really the opposite. Then I also gave you naming review worksheet. This is your, someone here seems to like study guides. I didn't put any physical change stuff on here, though, because I've usually found kids wrap their brain around that pretty quick. I found what they need lots of practice with is name to formula, formula to name, especially with the Roman numerals and the polyatomic. So I'm going to put an answer key for this online. This is also going to be and by mark it, I mean, don't give yourself a score, but check your answers, because it's possible to do this totally wrong, Kiana, and have no idea that you've done it totally wrong unless you check your answer. Or check with a neighbor, strong neighbor. Is that okay? Now, the last thing that I had here in the PowerPoint and on your notes was this textbook assignment. Far as I'm concerned, but if you feel you want more studying, knock yourself out. I'm not going to collect that. That's optional. But if after this you're saying, I'm still getting some stuff, or you could even look through it and say, oh, I don't know how to do that question. Well, that might be one to practice. Oh, I know how to do this. I know how to do that. Well, then don't waste your time, Kiana. Don't do them. Does that make sense? Any questions on? So you're going to get the rest of this class absolutely, absolutely, absolutely get take-home quiz 2 done. Tomorrow, which is a short day, it's a late start day. Oh, pause the video for a second. So tomorrow, we're marking this quiz, and just to let you know what I'm going to, Rihanna? Guys, I'm talking. Tomorrow, I'm going to give you this. This is a pretty big review, but I wanted to give you an idea of what you might see for like multiple choicey kind of questions. This is what you're going to work on tomorrow, and this is what you'll mark on Tuesday. This won't take you all class on Tuesday, so you can also on Tuesday use that to study, to get any other missing work done or anything like that. Now I'll shut up.